Hello everyone, good morning. Okay, so today guys we are going to start with set, right? In the last session we discussed about collection framework and list interface only we have completed so far. Today I will be discussing what is a set interface and how to use it, how to implement it, right, in the real time. So the point is set, okay, we have discussed two differences between set and list. List is always order collection, correct? Set is not at all order collection. So in set, if you insert some element in same order, you will not retrieve those element. Okay, so order can be anything, random. Second point is in list interface, duplication allowed, but in set interface, duplication is not allowed. Remember, so it will always hold unique elements only. Fine. But now it is interface and we have a rule. If you have interface, interface has to be implemented by the child class. So when you discuss set interface, just have a look. Three child classes are there. Okay. First is which is very commonly followed. That is HashSet. Under HashSet, technically we have linked HashSet, and then we have TreeSet. Okay, class. And TreeSet is also implemented sorted set. Clear? So basically sorted set extend set interface. Remember, interface to interface relation will be extend and then interface to class relation will be implement. Correct? That's the reason this is the relation. So let's understand for what data structure we use has set, we use linked has set, and in fact we use tree set. Okay. So very first, if I can create a new class. Okay, last session, see, linked list, vector, and array list we have completed. Now let me create a new class. So this topic is important for, okay, your interview. Very important, right? People will ask you a lot of questions on collection framework. And that's the reason I'm trying to cover internal data structure or how exactly that particular, okay, structure will work, every point, so that you can prepare it well. Okay. So let me show you first example, which is a hash set. Okay, hash set demo. Because these are ready-made classes, everyone. So you need to write not only hash set, but along with that, write example, demo, anything. Okay. So this is the first demo on hash set and just have a look what is hash, right? So few key points, let me write. Okay, let this work. Now I'm just going to add some document. Okay. First point, hash set is class, implement. Remember, set interface. Okay. Now underline data structure. Underline data structure. Okay, for hash set. Okay, is I will say hash table. How hash table will work? That is another point. Okay. So internally hash table stores the element as per the hash function. Okay. So let me write that. Hash table store elements. Okay. Elements as per hash function. Okay. Hash function where you will get key and its indexing. Okay. Now, what is this function? How it is calculated? I will cover that point. Don't worry. But just understand how it is working. Okay. So hash table is a data structure in Java. And with this table, you are able to store the element into hash set. Now, the point is duplicate elements not allowed. Duplicate elements not allowed as it is set interface. And second point, okay, it is it is an unorder list. Sorry, unorder set. Remember. So generally this is an order set. Okay. So you are not able to maintain the order, right? And these points are enough. Now let's see how we can use set interface. So guys, first important topic is, let's say what I wanted to do, as I told you, set always store unique element. So let me start with has set. Absolutely. All these classes are predefined. You just need to create an object. If I write, okay, has set, let's say generic syntax, integer means I wanted to store here integer type of data. I'm writing HS, it is equal to new. And again, I'm writing has set, class object. So again, let me write integer. Great. And this is constructor. These classes are the part of java.util package. Just import it. Once you import, right, now all the method of collection remains same. So set is also child of collection interface. That's the reason all methods are same here. What we can do, let's say initially I wanted to test, okay, is set empty? How we can test it? So here you can apply the simple method hs dot is empty. If it is really empty, you will get true, and then otherwise you will get a false result. So at this moment, set is empty. How we can add the element to the set? So we have add method. Let me add hs dot add. See, and initially we can add that particular element. So let me add, okay, in a sequence manner. Let me add the element in a sequence manner. I'm just adding 100, 200, 300. hs dot add, let's say 400, and I'm adding hs dot add, let's say 500. So total 5 elements I have added. Let me add some duplicate. Let's say 200 again, I'm repeating. And let's see, whenever you try to print HS, okay, let's say one more time, set is empty. No, this time set is not empty. Definitely you will see the result. HS dot is empty method will show you the result false because this time set is not empty. But the point is, I would like to print that set. Okay, so we have a direct way. As we are dealing with object, directly that object you can print and you will see the set. Okay, but there is a one more point. I would like to capture total, total elements in set, right? Total elements are, and there I will be writing hs dot, yes, size method. Remember? So these methods are common, right? Now please have a look. One more point. HashSet is child class for set class, correct? I mean, set is an interface. But internally, what we discuss, it is not at all order. Means if I insert now in a sequence 100, 200, 300, but at the end you will get result in a random order. So first of all, duplication not allowed, and this is not at all sequential execution or class. So please have a look. If I run this, how the output I am getting? At this moment, I'm getting completely random result. See, I have inserted 100 first, 200 second position, but see the data 400, 100, 500, 200, and 300. Correct? And even you can observe 200 I have added 2 times, but it is not accepted by the set. Set is only hold unique element. That's the reason I'm just getting total elements are 5. Okay, are you getting this point? Now, question is this class, and there is a one more interface we'll be learning, which is called map interface. There is also one more interesting class available to implement map interface, that is a hash map. And in interview, there is a very famous interview question, how internally hash set or hash map works. Okay, you need to understand how the hash map or hash set both classes will internally work. The best part is what? In both the classes, we use data structure that is a hash table. Hash map also based on the hash table internally. Underlying data structure is hash table, and hash set also based on hash table. And that's the reason it is important to know internal architecture of this, how it is working. Now, when you talk about hash set, guys, difference is at a time we are able to maintain one single element. Hash map, it is all about combination of key value pair. Map is a very special interface where you can store at a time key along with its value. But what is that key? What value it will store, right? How it will store? That structure and hash set structure both are same. Means internal working mechanism for hash table, it is always same. So people might ask you what is the initial, okay, capacity for hash table or hash set, how it generally store the element. So guys, please remember initially, okay. So I will say initial, better initial capacity, okay. Capacity for hash set. Remember for hash set or your hash map, okay, or your hash map. Let me write that. So hash map is not a part of set interface. It is a separate interface available in Java, which is map. But internal concept remains same. So both initial capacity for hash set and hash map is, I will say 16 location. Means initially if you declare how much memory it will occupy, it will create 16 empty location. And inside that 16 empty location, as per the node structure, it will store their data. How come this is dynamic? That is the point you need to understand. It will store a data as per the particular, okay, table or as per the node structure. So you should know node structure for hash map or hash set. Let me tell you, there are 4 partition into node. Okay. First is all about key. Second is what? Hash, hash code. Third is it's all about data, what data we are storing. And fourth is it is address of next element. Remember, as a linked list, it is internally stored in this manner. Okay. So let me explain you first data structure, how the table work internally, and then only you will understand this part. So guys, as I discussed, hash table is another interesting data table, or we can say data structure, which will help you to store the data. Correct? But how it's stored internally, please have a look. Initially, when you declare hash set object or hash map object, you will get 16 location. Okay. So let's say this is my table, and currently in this table, I'm having total 16 location. So let me just write randomly. Consider this is the size 0, 1, 2, 3, 4, 5, right? 6, 7, 8, and let me write up to 15. Means total 16 location. And this is what we are discussing hash table, guys, which is internal data structure for both the classes hash set and hash map. But how it store the data? As I told you, it store the data as per the hash function. Now this algorithm you need to understand. Just to show you the concept, I will take some information. Let's say I wanted to store here some fruit detail. Okay, my first fruit is mango and second fruit is, let's say, banana. I wanted to store these two fruits in this table. How the fruit you are able to store? The very first, it will calculate one hash function. In hash function, you need to pass that fruit. For example, I'm passing mango. Whatever fruit you are writing, what this function will do? This function will be internally called and this function will be calculate hash code and index value for your data. Means here, if I call hash code and if I just identify the index position, so just have a look. Generally what happen? It will first calculate hash code and the key. And based on the key and hash code, you will get index position. Okay, so let's say we got hash code something around 9990009. Okay, and we got a key. Suppose I'm taking key as a 101. Now, based on the code and key, you will get what? Indexing. Means there is an index calculated based on the hash code and based on the key. Let's say we got the indexing that is 3. Then what will happen? At third position, it will create one node structure. And guys, what this node structure it is? We have 4 partitions inside this node. One is for your key, second partition for hash code, third partition for your data, what data you wanted to store, and fourth one is for address of next element. So at this moment, key is 101, hash code is 90009, data is mango, right? And there is no next element. So we can directly keep it as a null. So what happened? Whatever position you will get in the indexing, at that position one node will be created and one structure will be ready. Got it? Now let's talk about same concept for banana. What will happen? Now you are passing banana to this function. What this function will calculate for you? Key and the hash code. Let's say this time we got something around 90000, let's say 8. I got 8 as a hash code. And I got a key that is 102. Based on this, let's say we found particular indexing. At this moment, I got 7. Okay, so what will happen at 7th number position? One more node will be created. And let me design this node. Hash code is, key is 102. Hash code is 90008. Data is banana. And again, there is no next link. So you can create a null. Okay. Now somewhere what happened? Let's say now I wanted to add orange, new fruit, right? Again, process remains same. Means algorithm will execute in the same manner. Again, orange will be passed to the hash function. It will calculate some code for you and key for you. Let me write key is 103. And suppose I got a hash code which is 7003. Okay. Whatever it is, guys, people will not ask you how internally hash code will work. That's not your responsibility, right? But internally, you should be able to explain the algorithm. So do not worry for hash function calculation and the indexing calculation. But all the points you need to remember. So absolutely, if I got some hash code and if I got some key, what I will do, I will get some, okay, indexing also. Sometimes what happen, two objects can have same indexing. Yes, sometimes suppose now at this moment also for orange I got suppose same indexing, then how it will generate that object, guys? At same indexing already one object is there which is banana. Now orange also part of a same index. First point, whenever two objects have a same index, this is called collision. Okay. So collision in hash table means what? Whenever two objects get the same index position, that will make a collision, guys. And how exactly this will be implemented in Java? So let me show you. Now already at 7 position, one node is there. Now they will create one more node internally, and here they will attach your next object information. Example 103, right? Then hash code is 70003, and let me write my data which is orange, and there is no next element. Are you getting my point? So this is the nature to make our code or make our data structure as a dynamic. Remember, how come it is dynamic? So based on linked list, it will be dynamic, guys. Because max to max, you will get only 16 location. But how it will store internally? Internally, again, you can see it is not a tree, not at all in a sequence. Correct? Whatever data you have inserted in the same manner, you will not receive the data. Because indexing can be anything. Got it? That's the reason you always get a value which is in a random order. Second point, what you need to remember, how it is dynamic. So internally it maintains node structure. And because of this, it is dynamic. Are you getting my point? What is collision in hash table? Whenever two objects get the same index value, then it becomes collision in hash table. Okay, but there is another question. Can I insert null value in the hash table? Answer is yes. You can insert null value in the hash table. But another question will be, what is default value for hash code? Or let's say what is hash code and indexing for null? Let me tell you, key can be anything for null. Whenever you try to insert null value, hash code for null, guys, always you will get 0. Hash code you will get always 0. And based on that, key can be anything. So suppose key is having 104. But index value for the hash code, it is also always 0. Means at what position null object will be created? Always at a 0th position, null object will be created. So let me design here. Okay. Now I am trying to insert null. So how it will be? Please have a look. Let's say I'm having key is 104, hash code is 0. I'm writing my data which is null, and there is next pointer which is empty. Again unknown. Got it? So this is what the main key point that you need to remember for hash table. First point, it is a table which can store a data as per the key. Okay, whatever key it is, based on that you can store the data. But internally, it calculate for every object hash function. Within hash function, you will get hash code as well as key. And based on key and hash code, you will get indexing. Then as per the index position, internally this table will create a node structure and it will store the data. This is main data structure architecture which you need to remember. Okay, this is common for both the classes hash table and hash set. So if I just come back to the code, right? Let me show you. Now I'm trying to add here null value. Okay, see. So sorry. Let me write here hash code and index. Okay, indexing for null is always 0. Remember. Fine. So let's see where I am trying to add at the end. Correct? And if you observe the previous example, I mean, what is the output of this code before null? This was the output, correct? So currently the list, I mean, currently whatever set you are able to see, there are 5 elements, but elements are completely random. I follow the order 100, 200, 300, but I'm getting random result. Okay. And what we have learned, every time if you try to insert null, index position will be always at a 0th position. So let's see this. Now let me save the code and I'm just trying to run it. I'm adding null at the last, but see where it is coming. So now here again we are getting something different result. Right? It should be at a 0th position. Let me check. So if I can just observe this null, So why the null is not coming at the zeroth position? Or maybe they have changed internally this architecture. Okay, fine. Let me run it again. But we are getting null at the second position. Okay, it should be actually come at the zeroth position. Fine. But at this moment, just understand null value is also inserted. Okay, what is else? Like other methods remain common, right? If you wanted to look for specific object, then we can have contains method. Means suppose I'm writing, look for let's say 300, whether 300 is a part of set or not. So we can write, okay, fine, hs dot contains, and there we can add that particular, okay, 300. Which object we are looking for? Integer 300. If 300 is a part of set, you will get true result, boolean result, otherwise you will get a false result. Okay. Now, rest of the method, let's talk about remove. As you can see, set is not at all based on indexing as it is unordered collection. Okay, it will not give you answer in the order format. That's the reason whenever you wanted to remove the object, you need to provide the name of that object which you wanted to remove. Example, if I just say hs dot remove, right? So here we can pass a object name, not indexing. In list interface, we have to pass index value. But here, let's say if I write, I wanted to remove null value. Fine, I don't want unknown value in my set. Then you can remove. And if you try to print it, you will see the result. Just have a look. Now, if I execute the code, I'm getting what? Yes, 300 is a part of the set. True. And here I'm getting that remove value. Which value we have removed? Null value we have removed, right? So previously we have added it. Now we are trying to remove it. And yes, it is working fine. Similarly, set also you are able to clear. Just you have to write hs dot clear. Correct? When you say hs dot clear, absolutely set will be empty. If I try to print in that case set, and if I try to print hs dot size, remember size will be 0 as there is no data, no element available. And what set you will get? Absolutely, we are expecting empty set. It will not throw you any exception. So let's run it and let's observe. So at this moment, just have a look. I'm getting empty set and size is 0. Because of the clear method, every element from the set we have deleted. Correct? So that's the reason these methods remain common for entire collection framework. Got it, everyone? So remember what is a HashSet? HashSet is a class and which implement list interface. But how it internally works? So it internally store the data as per the hash table. And hash table is completely based on hash mechanism, means hash function, where you will get some key, some hash code, and based on that you will generate some index. And as per the index position, it will create a node structure. And remember, for null, hash code and index position always 0, right? So this is what the main part you need to remember for hash code or sorry, hash set. But one more point, guys. What if I wanted to iterate? Yeah, we do you remember? We learn in list three techniques. One is based on indexing, we can iterate. Based on simple for each loop, we can iterate. And third is using iterator. Now tell me here, if set is not at all based on indexing, then in that case, we can't iterate using first technique, which is normal for loop. Are you getting my point? So basically, how many ways are there for iteration? Only two. For set. So let me show you. Iteration using for each loop. Okay. First of all, it is possible to iterate using for each loop. How to write a for each loop? Everybody knows the syntax. You will be just writing for current set is a type of integer, right? You can see here what the type we have declared. We declare it is a integer type of set. That's the reason what I can do. I can just declare, okay, this is integer. Let's say I colon, and I'm passing object name, which is hs. And let's try to print ith value. So here we don't deal with indexing. Technically, set is not at all based on indexing. It will always give you random result. And that's the reason if you iterate or if you execute it, you will see the result. Now I'm getting, okay, we are printing it. And why it is not printing? Let me check it out. So system out println ith value I'm trying to print, but I'm getting empty result. Okay, just a minute. Let me check why. Oh, How come it will iterate? Because we have cleared the list, है ना? So better let me comment it. Okay, clear part, I'm just trying to comment. That's the reason it is not iterating, because it is empty. Set is empty, right? Let me comment that and let me run now. You will get the result. Perfect. So this is how one way to iterate your set. What is the another way, everyone? We can't follow indexing, right? The second way is using iterator method. Yes, we learn it in list interface, correct? Iterator is very special method, and it is a part, I mean, this method is available in iterable interface, which is a parent interface for collection framework. So if you wanted to use it, how we can use it? Return type of this method is iterator interface object. And what will happen when you apply this method? When it will return to you, there are only two methods to use, has next and next method. So we will first confirm whether elements are there in the set. If yes, then we will get that element. Means logic you have to write in this manner. First of all, set object. Then I can follow this method iterator. And see, return type is iterator interface. So better I will declare it. I have to write, okay, iterator, correct? Interface of integer type. Current set is integer, so I'm writing same type. Let me declare this iterator. And let's import iterator directly from java.ut. So keep your mouse pointer and you will get the same option. Java.util you can import. And there I can put the while condition while IR has next element, means in your iterator, if it is next element present, then we are trying to print it IR dot using next method. That's it. And if you run the code, you will able to see that set information. Great. So both the ways are possible to iterate any set, right? So guys, these points are clear. Okay, what is set? So set always maintain, okay, always it will not allow you duplicate value, and first of all, it will always store unique element, right? Set is not at all order collection. But guys, there is another question. People might ask you, suppose you have a list, okay, and you wanted to delete the duplicate elements from the list. How you will delete that? Okay, please have a look. Example, in the last session, okay, we have completed only linked list and vector, right? Okay, let me create here one more class. Just have a look. Huh? I'm writing here collections demo. Okay, so collections is a very special class in Java. And with the help of this class, you are able to perform multiple operations on your list, as well as, I think not on set, but yes, on list, we are able to do that. How you can sort the set, I will explain you that part. Okay, just focus. So what is this collection class and how it works? So generally it has some method, okay? Let's say sort method. If you can just have a look, let's say you wanted to identify minimum element, maximum element, everything is possible with this help of class. So guys, last session, if you remember, we discussed add all method. That is also possible in collections class. So Java provides you two interfaces. Okay, two, I mean special classes. One is an interface, another one is a class. Collection is an interface which you are learning. Okay, collections, it is a class in Java. Okay, only S is different. So remember, collections is a class and collection is a framework. And what is the beauty of collections class? This class has its own method. Those are static method. Means method you can call directly by calling class name. So example, if I declare in this manner, just have a look. Array list, and I'm writing here, suppose integer type. Okay. Now I'm writing here, it is equal to new. Again, I'm writing array list. Okay. Same type, integer. And in fact, what I'll do, I'll just add some element. Let's see, I'm adding al.add. And guys, here I'm trying to add that element. Let me just add, suppose 90. Okay. Please have a look. I'm trying to add 90. Then I'm adding al.add, let's say 20. Okay. al.add, let's say 77. Now I'm adding al.add 10. Okay. Then I'm adding al.add, let's say 89. Okay. So I'm just writing some random number. And this is, you can see, like these numbers are not at all in list interface is always order, right? So if you try to print, you will get in the same order. The way you have inserted the element in the same order, it will retrieve. Great. But guys, I wanted to perform some operation on that list. Very first, I wanted to sort this list. How it is possible to sort this kind of list? Remember, directly we have a method which is a part of collections class. Then I have to write that class name first. Collections dot, when you put, you will get the method. If I just use sort, please have a look in sort method. We are able to pass what? Only list. So this is not applicable for directly set interface. Try to understand. Here you can see that we are passing only list, and then whatever list you are passing, you will get sorted result only. Just have a look. If I print here now AL, so result you will be getting in the sorted manner. Okay, now you can see. You have inserted this list and you got the result what? Sorted elements only. Now I wanted to identify mean element. Okay, so can I do in this way? See, mean element. So how you will get that mean element, everyone? So I will be writing AL dot, basically not AL, collections. Collections class dot, okay, mean. And in mean, you have to pass collection where you are looking for minimum number of element. So out of this all element, minimum number you can see which is 10, right? So we are expecting 10 in the output. Similarly, max element. I wanted to identify max element from this current list. Again, you can apply in same manner. Collections, which is a class, dot max, and pass your collection where you are identifying max element. So absolutely in current example, 90 is the max element. So if I run, please have a look. I'm getting 10 and 90. Okay, 10 is the minimum element and max is a, what is this max element, which is a 90. So are you getting this point? How exactly you are able to perform operations on that list? Now let's talk about our question. What I wanted to do. Okay. So I wanted to declare, let's say, uh, let's write a logic, okay, write a code to remove duplicate elements from, okay, from list. So consider you have a list and you are having some duplicate element in that list. So let me do one thing. I'm just trying to add some more element, okay, which is duplicate. So I'm writing, okay, 90. One more time, 90 is duplicate. Okay. AL dot add, I'm adding 20, which is also duplicate. Fine. AL dot add, I'm trying to add 15 also, which is duplicate. Three elements which are duplicate. And now I wanted to write a code where I can remove the duplicate element from the list. Question is how you will do that. Guys, what you need to do is you need to write a manual logic, right? Normally, how we can write a logic? Okay, I have to iterate list first of all. Compare each and every element object. If there are similar object available, means first object and next object both are same, right? Then I just wanted to increment that counter, or I will put the direct method remove method where I can pass that index position and I can remove the element. Got it? So generally that was the manual logic and quite complicated. You need to pass indexing and all, and finally you will delete the element. But what is the solution? We have a list and list have duplicate element. That is fine because list allow duplication. But guys, we have another data structure which is set. Set will not allow duplication. So there is a direct simple code or simple, I will say, solution for this scenario is what? We will convert. What is the answer? Answer means here you can write this scenario what? We will convert. Convert, I will say convert list into set, and it is possible. If you convert your list into set, duplication will be automatically removed. But question is how you will convert it. So please have a look solution. So let me design what? One set. I'm writing has set. We have learned na has set. Okay. But for conversion, whatever type of list it is, you should have a same set of type. Okay. So set is also integer type. Let me write integer. Great. This is HS new. Any name you can write. And again, I'm writing same hash set. Again, integer type. Okay. So let me design integer. And this is the constructor. Now, guys, first point is we have learned that if one collection you wanted to attach in second collection, so either you can follow this method, add all, correct? If I follow add all method and whenever you will pass any collection to it, what it will do? All the elements it will store into this set, and whenever you try to print set will automatically remove duplication. So just have a look. If I pass here, which collection, guys? Absolutely, I'm passing AL, right? So two ways how we can remove the duplication from the list, convert list into set. And for conversion, we have two ways. One, using add all method, remember, and second, using constructor. If you follow constructor way also, you can pass your list to set and you will convert. Now please have a look. Here, before conversion, I'm trying to show you AL. Okay. And now after conversion, I'm trying to show you, okay, AL. So at this moment, but AL or HS, we are converting and we are removing the duplication, so better HS, right? Final set is what? List we have converted in the form of set. So let's print the set now and just have a look what result we are getting. So initially my AL is a order collection. So you can see what the element I'm getting. Now it is sorted, no? We already sorted. So we are getting in this manner. And where you can see duplication allowed. But then if you convert into set, always you can observe how the result is coming. Result is coming in the, first of all, it is not at all order, but duplication allowed. No, duplication remove. Can you see that? All the 15, 10, and I guess one more 90. Okay, 20, 10, no, 15, 20, and 90. All these three elements got removed. Okay, automatically remove. So you don't need to write that manual logic. It's a simple interview question. If you have a list and there are contained some duplicate elements, how you will remove it? So you just need to answer, we convert list into set and then it is possible. So generally set will maintain only unique element. That's the reason duplication not allowed. Clear? But one more point. What if I wanted to make this set in the form of sorted? Can we make set in the form of sorted? Like, do we have collections method for that? Usually collections class that work for the list, right? We don't have a direct set method where you are passing set and you are getting the result. Let's try. So if I just come to the next line and if I say, okay, collections dot hs, okay, sorry, collections dot sort, and then we are passing hs into that. Okay. So this time, if you can observe, this is not allowed. Correct na? I can't pass set interface object into sort method. But if I say AL, that will work. List is allowed. So remember, for set, we can't use sort method. But then what I can do again? Again question. Now I'm getting the result, but I wanted to sort set information also. Basically, how to sort any set? That is a question. So can we do in this manner? Can we convert set in the form of list and then list we can pass to sort method and we are able to convert it. I mean, we are able to sort it. Yes, guys, conversion, any one type of collection into another type possible. So basically, what is the solution here? Let me add this point. Okay. How to sort any set? So I'll say solution, right? Solution is convert set into list and use sort method. Are you getting my point? See how to do that. Now I'm already having set. Let me design one more list. So I'm just writing list of same type integer. Let's say this is L1, it is equal to new, and I'm declaring object of array list. Okay. And here I'm writing integer constructor. Done. Let me import list interface from java.util. Now let me show you collection constructor technique. What I can do, current has set, I will pass in the constructor of array list. And then if you try to print L1, okay, guys, you will see the same your set, whatever set information it is, same elements you will see. So let me just show you this part first. Now HS contain this part, right? See, in same order, list is order. So in same order, you are able to see that particular data. But now we wanted to sort it. Then I can do what? I can follow collections dot sort method and where I can pass L1. And when you pass L1 to this sort method, and then after that, if you try to print L1, actually you have sorted your set. Correct now? So you can see Set we have passed to list, and now last result I'm getting again in a sorted manner. So these are some interview scenarios, guys. How you can sort the element for list, how you can sort the element for set. So this is how you guys are able to sort the element for list and set. Okay, so conversion is possible, list to set to list, we are able to convert. And then we are able to perform this operation. If you convert list to set, duplication will be automatically removed. If you convert set to list, you will get order collection. But the point is, if you wanted to sort it, you can use sort method only for a list interface. Got it? So these are some common interview questions that you should know. Okay, how to use set interface in Java. Okay, but only one data structure we discussed, that is a hash set. Now there are two more which we need to learn. One is a tree set, another one is a linked hash set. Okay, so now let me explain you tree set. We have a time, so let me continue with a tree set. Just have a look. If I can declare a new class, tree set demo, and let's understand the purpose. Okay, what is this data structure, how it works, based on which internal structure it based, right? Everything we should know. The first point, tree set is class. Okay, implement same. Okay, at this moment, first of all, it implements sorted set, correct? So sorted set is another interface and which extends internally, okay, set interface. So this is the relation. Tree set is a child for sorted set and sorted set is a child for set interface. Okay, what is underlying data structure? Underlying data structure is, okay, which is called binary search tree. So binary search tree, what is this search tree? We need to understand first. Okay, then guys, let me tell you again, because of the sorted set implementation, tree set, tree set always return you result. Tree set returns sorted set. Remember, so we have a direct solution. Can we do in this manner? If tree set always return you sorted set, right? So if I pass my hash set data into tree set, I will again get what? Sorted result. Then I don't need to convert na into list interface. So we will see this example too. Because tree set, if you follow, it will always give you sorted result only. Okay. And the rest of the part remains same. Like duplication not allowed. In fact, indexing, it is not based on indexing, or I will say it is not order collection. Okay, so it is unorder collection. Again, same rule. Now, guys, let me show you how you can declare a tree set and how it works. So first of all, let me write tree set. Again, I'm declaring suppose integer type. Okay, ts, it is equal to new. And let me write tree set. Guys, first of all, it is time to understand algorithm. Then only you will understand how this code is working. Correct? Now let me show you how tree set internally work. So it is all about a search tree. Means just to search element. We use this data structure. But what does search tree and how it works internally? Remember in tree, you will be having some root node. Okay, some node will be considered as a root node. And in root node, there will be two parents, I mean two child. One I can say left hand side child and right hand side child. Let's say I'm writing A and B. Then there might be possibility for A and B. Again, you might have multiple child. Okay. And when you say binary tree, always remember binary means every child, okay, every parent must have two child. That is called binary. But at this moment, this search tree can be dynamic, right? Means there might be possibility I can have one child only. I can have many childs, multiple childs under that. Maybe I'm having one more and there is another child. So generally, normal structure we can call search. Okay, search. So when I say binary, that will be restricted to only two. So I will write here, actual algorithm is search tree and that is enough. So how we can use this algorithm? Please have a look. For this, I will be writing some numbers, means some elements which I wanted to add. So let's see, I'm writing here 10, then suppose 6. I'm writing here 3. I'm writing here 8. Now I'm writing here 9 and 1. let's say 4. Okay, let me write 15. And let's say I'm writing here 7. Okay. So total, guys, what will happen? These elements I wanted to store. How algorithm works? Total how many elements? 1, 2, 3, 4, 5, 6, 7, 8, 9. Total 9 elements. First it will calculate mid element. How the mid element you will get? 9 divided by 2. Correct? 9 divided by 2 means what is the output of this particular division? So we can say 2 fours are 8. Correct? 2 fours are 8. And then we need to apply the point decimal and then we are able to divide this number. But here, the point is 4 will be considered as the index position or the root element. Whenever you identify integer division, answer will be integer, not double. Remember. So I will get 4. So what is fourth position data? Whatever fourth number it is, whatever position available, I mean whatever data is available at that position, this will be considered as a root node, right? Then algorithm says that whatever elements are less than root, okay, less than root, that we can keep it at left hand side. And whatever elements are greater than root, okay, or I will say, here comes the point, less than means root should be greater. And I will say elements which are greater than root, those we can keep it at the right hand side. This is simple algorithm we are having for search tree. Now guys, let's see how it works. When you capture here the mid one, you will get fourth position data. 1, 2, 3, 4 means I found 8 is a mid element at this moment. Okay. Then I will design in this manner. First 8 will be considered as a root and there are two partitions, right? Now let's see. What will happen? Left hand side whatever elements are and right hand side whatever elements are, those are converted into two part. Partition into two part. And now let's start with first set. What is the first value? 10. 10 is what? Less than 8 or greater than 8? If any element is greater than 8, we can keep it at right hand side. Means it will come here. 10. Okay. Next element is 6. 6 is less than 8. It will come here. Then 3. 3 is also less than 8 and less than 6 also. So I will make it here, that node. So one set is completed. Let's move to the next set. 9. 9 is greater than 8, but 9 is less than 10. So I will declare at the left hand side. Then we have 1. 1 is less than 10, less than 6. In fact, it is less than 3 also. So left hand side. Okay. Then we have 4. 4 is less than 8, less than 6, but it is greater than 3. So I will declare here 4. Great. Now we have 15. 15 is greater than 8, greater than 10. So I will declare here 15. And last is 7. What is 7? 7 is greater than, less than 8, but greater than 6. Then 7 will be declared here. Now, how it will capture all the node? Please understand, it will start with leaf node. Okay, leaf node to root. That is the flow. Means it will start with 1 left to right and leaf node to root. So 1, 3, 4, again root, again leaf, again root, again leaf, root and leaf. And what you got? If you just write the numbers 1, 3, 4, 6, 7, 8, 9, 10 and 15. So this is how you will get sorted result by default if you follow TreeSet class. Are you getting my point? So this is the data structure which we can call search tree. This will help you to search specific element from that set. And always remember, TreeSet, TreeSet class is always give you, HashSet is always faster than TreeSet. TreeSet has a performance little bit slow. Why? Because internally it has to follow this algorithm. It will capture every element. It will compare whether it is less than or greater than, right? And then only it will form the tree. So always remember HashSet is always faster than TreeSet. And that's the reason when you follow TreeSet, you will get always, okay, result in the manner of what? I will say sorted result. Is this point clear? Let me show you same example. So I'm just writing same numbers and see the result. 10, 6, 3, 8. Let me write ts, okay, ts dot add 10. Then I'm writing ts dot add 3. Okay. Ts dot add 6. Then I'm adding ts dot add, let's say 8. Okay. Now let me add 10 6 3 8, 10 6 3 8, and hmm, 10 6 3 8. So let me replace the values. And then 9 1 4 15 7. 9. Okay. Ts dot add 1. Then ts dot add 4. And then ts dot add 15. Correct. And finally we have ts dot add 7. Great, everyone. Now please have a look. If I just print ts, it will always return you sorted result because of the search tree algorithm. Got it? Same output 1 3 4 6 7 8 9 10 15. Same output which I have shown you through this algorithm. So are you getting my point? There is a direct class available in set interface which is tree set. When you pass element to tree set, it will always return you sorted result. So let's try the previous scenario. If I come to this collections class demo, right? We discussed this part, how we can sort any set. So I have shown you one technique where you can convert list set to list and then you can apply sorting technique. Let's do one thing. Already we have has set now. If I comment this part, now I don't want to convert it. And let's try with tree set. If I declare here, let me create a object, tree set. Let's say same type, integer. Okay, ts, it is equal to new. And let me declare here tree set of integer, right? Constructor. And what I'm trying to do now, let me import tree set from java.util package. So currently, this is what set we have, right? And HashSet is always give you a random output. Okay, so I will try to show you HashSet here first. Now what I wanted to do is this HashSet I wanted to sort. So better I will pass it here in the constructor. And if I print this time TS, what do you think? You will get sorted result only? Yes or no? So let's see what HS it is and what sorted result it is. Perfect. You can see this is HS we are passing, last output, and this is what the sorted result we are getting with the TS. Means point is very simple. Either you convert set into list or you convert set into tree set. So another solution is what? I will say solution 2, right? And this is the solution 1, that convert, let me write here, convert set into tree set. Everyone, are you clear? So when you convert set into tree set, yes, you are able to sort the set. Easy, easy solution. Got it? So what is tree set class? It will always return you sorted result. Okay, and this is how you can apply the scenarios and you will get the output. But in tree set, I would like to discuss some more method. Okay, so just have a look. Few methods are common. HS like ts dot size method. If you see, you will get total number of elements in the set. But guys, there are three special method. Okay, I think head set, tail set, and subset. So let's understand what is that. If I can write here head set method. Okay, head set method. So what is this method? Please have a look. If I say ts dot head set, so read a document. In head set, we are passing some integer element and it return view of the portion of the set whose element are strictly less than 2 elements. Means if I pass here head set, so head set returns you less than element. Remember, less than element. Example, I am writing head set to 10. So what it will return to me? All the element which are less than 10, you will see in the console. Please have a look. Now these method are not a part of hash set. These are special method which is only available in the tree set. So please have a look. I have written 10 and all the element which are less than 10, you can see in your console. Easy? Now, there is a one more tell set. So let me write tell set method. What is tell set method? How it works? And what it will return? Absolutely greater than. And if I'm not wrong, greater and equal. Okay, greater and equal element. Let me write equal element. So if I can show you ts dot tell set, please have a look. So in tell set, you will pass one element and it will return you greater than element or equal to that element. Okay, great. Means if I say again 10, I will get including 10 all the greater number. But I think in our collection, we have written 10 and 15. So you will get only two elements in the console, 10 as well as 15. Right? See, very straightforward scenario. Got it? And similarly, we can try for subset. Okay, so let me show you what does mean by subset method, how it works. So guys, subset is like a substring. Okay, you just need to pass both the indexing and it will return you from indexing and to indexing, right? Means if I can apply here ts dot subset, so you are passing from and to both the element and see what it will return to you. This will return element from the range from element inclusive and to element exclusive. Means whatever two numbers you will write. Example, if I write, let me write 7 and I'm writing here 15. So it will start with 7. Okay, 7, 8, 9, 10, and instead of 15, last element it will not return. So up to that before 15, whatever elements are there, you will see in the console. So expected output it is 7, 8, 9, 10. Right? Let's see. And if I run this, please have a look result. So this time what result we are getting? Okay, let me run one more time. Java application and see. We got the same result 7, 8, 9, 10. But exclusive means last number will be not included. Okay, that will simple excluded. And these are the three methods which is not there in other set interface. Okay, or other set we can say classes. So remember rest of the method remains same. Remove method and all. Contains method is same. Size is empty. Everything same. But these three special method we have, somewhere in collection you wanted to return greater values, less values. In fact, you wanted to return any sublist or subset, right? That is possible using these three methods. Okay. So we have completed today only HashSet and TreeSet. Tomorrow I will talk about last class from set interface, which is linked HashSet. We will discuss some common interview question based on linked HashSet, and then I will start with map. Once the map will over, we will have one more session for exception handling and we will be starting everything with respect to automation. Okay, so last topic from Java, now we are learning. Focus collection framework is important and all these classes, their data structure are important to know. And so I'm covering it. Okay, so please prepare well and we will see remaining topic in the next class. Okay, thank you everyone. I hope you are understanding and learning the topics. Okay, do practice. Okay, and I will upload this code on GitHub also. Yeah, if you have any question, you can ask. No queries? Okay, so we have completed in the last session this part. Okay, and I think I have missed to share array list also. Better let me check the last upload and based on that, let me pass it. Okay. Yeah, if you wanted to leave, you can leave, no issues. So we'll be taking session for GitHub also. There you will get the clarity how GitHub we can follow, how we can use it. Let me log in into account. Let me check your repo, what I have uploaded at the last weekend. Okay, and weekday. Okay. So I uploaded Java day 24. Okay, 4 days ago. Hmm. Okay. So let me apply as a 25. Git add everything. Git commit. -m Java day 25 and git push -u origin to the master. That's it. Okay, so you can access the code from GitHub and do practice. Fine. Let's stop the session. Bye everyone. Take care. Have a nice day.
Thank you, ma'am.
Thank you.